So let's consider the carbon dioxide molecule. Now, another rule for Lewis dot structures is the most electronegative atoms go on the outside of the molecule So oxygen is more electronegative than carbon, so oxygen will be on the outside, so carbon will be in the center. So we already have the electron configuration of oxygen from before. So we have 2 lone pairs and 2 unpaired electrons. We need to get the electron configuration for carbon. So what we can do is look at carbon's configuration, and I'll draw the 2s and the 2p orbitals separately. So we have this electron configuration. However, if I take an electron away from the 2s and promote it to the 2p, then I'll have completely half-filled orbitals. And so carbon actually does this. And so I have 4 unpaired electrons around carbon. This allows carbon to engage in a variety of chemical bonding, making life possible. We're carbon-based organisms, and it's because of this electron promotion from the 2s to the 2p level that allows carbon to have the variety of bonding that it does. Okay, so now I'm just going to connect electrons that can be shared between the 2 atoms. And let's see, I have an electron here and here that I can connect. I have an electron here and here that I can connect. So that was giving me, so far, 2 bonds between each carbon and oxygen. And I'll draw the 2 lone pairs still. So now let's count the electrons around each atom. We'll do carbon first. We have 2, 4, 6, 8. Each line is a pair of electrons. So we have 8 around carbon. Let's do oxygen. We have 2, 4, 6, 8. So we have 8 around this oxygen, and the same for the other oxygen. 2, 4, 6, 8. So we have 8 around that oxygen. So each atom has its octet, or 8 electrons around it. So that would be the Lewis dot structure for carbon dioxide. I'll draw it over after drawing all my numbers. There we go. Okay, we see here that carbon and oxygen have 2 bonds between this. This is called a double bond, meaning 2 bonds between the 2 atoms. So a double bond is stronger than a single bond. Now let's consider the carbon monoxide molecule, CO. So we start with carbon and oxygen based on their electron configurations. We would draw these dots so we can start drawing lines between the 2. So far I have this. Now oxygen has 8 electrons around it, but carbon only has 6. And so we need to increase the number of electrons around carbon by 2. So if I move this pair of electrons in between carbon and oxygen, I can count them toward both carbon and oxygen. So I'm not taking anything away from oxygen, but I'm adding 2 to carbon. So then I would have a triple bond between carbon and oxygen, and each atom as its octet. 8 electrons around it. So this would be the Lewis dot structure for carbon monoxide, producing a triple bond.